Hello, ladies and gentlemen. This is Mr. Briggs coming to you from my class. Say hi, class.
Hi.
Oh, now be quiet. All right, ladies and gentlemen, today we're going to be doing Growing Investigation 2. This is where we start to dig a little bit deeper in how to write these equations and how to write these equations and things that we use in real life. And this is all about growth factors and growth rates. The problems are listed right here for Investigations 2.1, 2.2, and 2.3. If there's any errors or questions about them, make sure to find me. You can also find this list in your checklist. All right, let's go ahead and get started. All right. One of the things that you need to know is, first off, what is an exponential equation? Well, an exponential equation is an equation that has an exponential relationship. And if you paid attention to the last unit, you'd know what that is. It means it's something that we multiply to get the next answer. So we double every day or triple every day. It grows bigger and bigger and bigger and bigger and forms this really crazy parabola shape when we graph it out. So here's an equation. Mr. Briggs starts out with $600. He invests his money in a company that sells zombie insurance to the elderly in Florida. Think about it. The Florida zombies, they're practically there. Every year, he sees a 25% return on his investment. So show this as an equation, and after 10 years, what would it be? Well, we're going to start this out with, obviously, a y, right? Y. Y equals what? Well, how do we get this answer? We started here with $600. Okay? And we're going to multiply that $600 by a certain value. Okay? So $600 times what? What am I increasing by? I'm increasing by 25%. But am I going to multiply by 25%? No, I'm not going to multiply by 25%. I'm going to multiply by 1.25%. Why 1.25? Well, if I multiply it by 1, I keep my money, right? If it's 100%, it's just going to stay 600 forever, right? Because anything times 1 is itself. But I'm adding a 25% to it, which is why I put 1.25 times x to the, actually not times x to the x power. Okay, so what's that going to look like after 10 years? Well, after 10 years, to solve this, I would take 600 times 1.25 to the 10th power. And if I put that into a calculator, 600 times 1.25 to the, where's the exponent button on this calculator? To the 10th power, I end up getting $5,588 more or less. So apparently the zombie insurance business is very, very good. All right. Now there's a couple of things you're going to want to get down. One is growth rate. Now growth rate is the growth of an exponential relationship as shown by a percent. Okay? So if we say it grows by 25%, 25% is our growth rate. If I'm growing by 35%, it's 35% growth rate. So the example here is the rabbit population starts at 500 and grows by 35%. Now, growth factor is something else completely. Factor, when you think factor, think multiply. Okay, growth factor is the number you use as a base in the exponential relationship. So every year we multiply the rabbit population by 1.35. And once again, that 1 is for what you start with, and the 0.35, what you add to it, that is your growth rate. That's where your growth rate is shown. Okay? So, what would this equation look like? Well, it would start at 500, and you would multiply that 500 by 1.35 to the nth power. Okay? Because every year we would add what we started with and 35% to that equation. All right, ladies and gentlemen, make sure you get this stuff in your notes. Ask plenty of questions of your neighbors and of me, and have fun.